Hello and welcome to Mars TV with me, your guest host, Mr. N from STEM with Mr. N on YouTube. I'm an award-winning primary teacher specialising in STEM education, and this is part of a series of video collaborations between my channel and Mars TV. This week, I'm going to be showing you a simple experiment you can use to explore helicopters on Mars. Let's check it out. When spacecraft or rovers land on Mars, they have to slow down very carefully. Mars has much less air than Earth, so parachutes and flying machines work differently there. In 2021, NASA's Ingenuity helicopter became the first aircraft to fly on another planet as it took to the air on Mars. Scientists had to test many designs to figure out how it would behave in Mars's thin atmosphere. In this activity, you'll build a simple paper helicopter to explore how air helps slow down and stabilise falling objects. This is similar to how engineers test landers, parachutes and flyers for Mars missions. For this activity, I'm going to demonstrate how to make and test a couple of different paper spinners. You will need some sheets of paper, a pair of scissors and paper clips. You can find paper spinner templates online, or you can make one without a template. I'm going to be using a template from Science Buddies, testing different sizes and materials. The template from Science Buddies has two different sizes on it. I'm going to start with the larger of the two spinners. I'm going to follow the steps printed on the instructions, cutting round the solid black lines, folding along the dotted lines and attaching a paper clip at the bottom to hold in the folded sides. I'm going to hold it up high, drop it, and see how long it takes to reach the ground. Now I'm going to follow the same steps above with the smaller spinner on the template, again following the instructions to put it together. Once done, I'm again going to hold it up high, drop it, and see how long it takes to reach the ground this time. On Earth, air resistance helps slow down falling objects. The spinning blades of your paper helicopter create drag, which is air pushing against the blades, and that helps slow the fall and keep the helicopter steady. When you drop a paper helicopter, it takes a moment before it starts spinning and slowing down. You might notice that it falls faster at first before the spinning blades create enough resistance. If the blades are shorter, they produce less drag, so the helicopter drops more quickly. There may not be one perfect design that always falls the slowest, as different shapes and sizes and materials can affect how each helicopter behaves in the air. With that in mind, I'm going to change the material my spinner is made of. I'm going to glue a paper spinner template onto a piece of cardboard. Then I'm going to cut this out and continue with the same steps as before to make the spinner by cutting in the two sides and down in between the blades before folding round the various folds and attaching a paper clip onto the bottom. Again, holding it so the paper clip is towards the ground, I'm going to lift it up high and drop it, comparing the results of this spinner to the other two. You'll notice that with the cardboard paper spinner, it does not start spinning at all and instead just drops straight down to the ground. All of these have been dropped from above 6 feet in height. It may be with a longer drop that the cardboard spinner may eventually spin. However, with this test, it has been too heavy and, instead of catching the air and spinning, has dropped straight to the ground. This would be a disaster for any space organisation if their Martian helicopter dropped and crashed as soon as it tried to fly on the planet, because there's no one there to recover it and fix it. On Mars, the air is about 100 times thinner than Earth's, so there's much less drag. That's why NASA had to build larger, lighter blades for Ingenuity and spin them much faster than on Earth. By experimenting with paper helicopters, you're learning the same basic principles of aerodynamics and descent control that engineers must understand to explore Mars. These skills are crucial for designing safe landings and even flying vehicles that will help humans explore more of the Martian surface in the future. You can extend this activity by trying different materials, such as different types of paper, card, or even different types of cardboard or plastic. There are also different ways to make spinners, so you could experiment with other spinners and see what works best for you. You could also try making even larger spinners to see what difference that size makes. Well, that's all for this video. I hope you enjoyed it. If you did, please hit the like and subscribe buttons to stay up to date on all future Mars TV content, and be sure to visit my channel, STEM with Mr. N, for more experiment videos and other STEM education content. This has been STEM with Mr. N and Mars TV, exploring helicopters on Mars.